Okay, so in this video we were discussing spectrum. We discussed the absorption spectrum. In this video we are going to discuss the action spectrum. But let me just give you a little overview of what was absorption spectrum. Absorption spectrum, wait. So when you just talk about the absorption spectrum, that was how much light would be reflected. Reflected means which could not be absorbed, so that would be reflected. Second, you will see which is absorbed. So yes, we were done. Now in this video we are going to see what is action spectrum. In that absorption spectrum we discuss few colors and how exactly they do it. Yes, here you will see the graph which I made. Light would be absorbed, green, red, these all. Then the second was also the same. Then third was carotenoids. Carotenoids is simply like they did not absorb red, so red was deflected, whereas first blue, second green, which both were, these both were like absorbed. So, and you will find few types of carotenoids which I will discuss in this video. So let's get started with the action spectrum. Action spectrum simply means that on which effect, like this tells about the effectiveness. Now what does effectiveness means here? Effectiveness simply means how does this affect and tells about the process of photosynthesis. So you might have seen that if this is a leaf and this leaf is green, okay, but you I don't think that you might have noticed, but why this leaf is only in green color? So there's also a reason which I'll tell you. So this action spectrum tells the effectiveness in the sense that which light could be absorbed, which could not be absorbed. So which could not be absorbed, which would be discussed in this action spectrum. So we also have graphs of this. Let me just made a little. Here you see graph. In this side you will see rate of what? Rate of photosynthesis, whereas here you will see that a particular wavelength, here it will be started by 400 and ends with the 750. So absorption spectrum only tells related to photosynthesis. Okay, this should be crystal clear. Then rate of photosynthesis, how? If in this you will see that here, you will see a difference which I'm telling of absorption and action spectrum is that in this you will see combination of the peaks. In that you will see, you were seeing the only separation like one by one, chlorophyll A, carotenoids, chlorophyll B. In this you will see combination of the peaks. Okay, then here the graph would be like this would be gone, blue would be gone, then here green would not be gone, and red would be again increase. So oh god, the graph is like this is the red color which would also absorb, this is the blue color which would also absorb, blue which would be absorb, but this color you see is the green color which is not absorbed. When this is not absorbed, so we say, so now you can think why is leaf always green, because the color which is not absorbed, that is reflected. So when green is not absorbed, so that will be reflected. In this leaf you will see all the color, but the one which will be reflected is green because it's not absorbed. That's why we see the color on leaf that is green. Okay, absorption spectrum which tell the effectiveness, and that was effectiveness part, because that does not like absorb the green, so we see the green. And range was 400 to 750. And here you see rate of photosynthesis, the basic and good difference which was, in this you will see combination peak and combination of the peaks and related to photosynthesis. So particular definition for this is a graph which could be plotted to check the effectiveness of what, of light absorption, because light absorption is also the same here, because light absorption, light means photo means light. So in this you will see photo absorption, because photosynthesis, this is related to photosynthesis, absorption wasn't. So in this you will easily say